Okay, we've got a 6 marker here. Let's have a look. So they typically start with a bit of context. They describe a situation. So let's see what we have. Scientists investigate the safety of seatbelts. Okay, so safety, I might underline that. We've got 2 cars. Each car has an identical dummy in the driver's seat. Both cars are crashed at the same speed into identical barriers. Okay, so 2 cars, everything seems to be identical. Same dummy, same speed, same barriers, but they're both crashed. So far, no difference between the 2. In one car, the dummy is wearing a seatbelt. In the other car, the dummy is not wearing a seatbelt. The one not wearing a seatbelt hits the windscreen in the collision. It kind of implies that the one wearing a seatbelt doesn't. Okay, so context is fairly straightforward. There's a picture to help us understand it. So yeah, the car's properly crashed. We're interested in the well-being of the driver, of course. So we're using a dummy. That's just sensible. We've got some results down here. So I've got some quantities here. I've got mass. I've got distance travelled by the dummy. Distance is s. Time taken for dummy to stop moving. T for time. Deceleration. Well, that's another word for acceleration. So that's like negative acceleration, slowing down. So acceleration is a, and stopping force F. Okay, so I've got some quantities. I've got a crash with a seatbelt and a crash without a seatbelt. So I've got car 1 and I've got car 2. And then we've got some information in each column. Okay, it's really important to understand the context. Okay, take the time to understand the context, the situation that they're describing. Take time to absorb the information provided. Okay, they don't give you a table without you having to sort of make some kind of reference to it. Really, there's going to be some information here we're going to have to use or at least refer to. All right, everything's here for a reason. Okay, so we've got mass. It's the same for both cars. That's the mass of the dummy, of course. The distance travelled by the dummy while stopping is different. The time taken for the dummy to stop moving is different. The acceleration is different. The stopping force is what's missing here. Okay, so that's a clue as to what might be in the question, because of course we haven't had a question yet. We've just had context and information. Okay, I've spent a minute or two just getting my head around that. Well worth spending the time. Here we come to the question. Calculate the missing data and use the information in the table to explain how seatbelts reduce injury in a crash. Okay, so yeah, so we're interested in injury to the driver or the passenger. Okay, I think it said somewhere we're talking about the driver because the dummies in the driver's seat. Okay, and it's a 6 marker, 6 marks. So look at that as an opportunity. Don't let it intimidate you. 6 marks is an opportunity for some marks here. You don't have to get all 6. Okay, the quality of written communication will be assessed in your answer to this question. That just means that your answer should be clear. Okay, one way to be clear is to absolutely think of some sort of way of structuring your answer, and there's usually clues in the question as to how you might structure your answer. So let's have a look. Let's just go back to the question. Calculate the missing data. Well, that's one thing I need to do. Okay, that is just one question on its own. And use information in the table to explain how seatbelts reduce injury in a crash. Well, I need to explain how seatbelts reduce injury in a crash. Some more marks. If I really want to get all marks, I need to use the information in the table. So I've got to calculate the missing data. I need to explain how the seatbelts reduce injury in a crash, and I need to use information to do that. Okay, I can calculate the missing data and explain how seatbelts reduce injury, but if I don't use information in the table, then I'm probably only going to get 4 out of 6, aren't I? Okay, so I've kind of broken it into 3 little sections. How you structure your answer is up to you, but I do recommend you structure your answer in some way. Okay, let's do the missing data bit first. I'm going to put a 1 there just to prompt myself. Okay, the missing data is this box that we noticed earlier. What have I got in that missing box? Well, I've got a crash with a seatbelt, something in newtons. I've got a crash without seatbelt. Okay, that's going to be in newtons also. I want to calculate stopping force. F is the unknown here, so that's what we're looking for. F equals what? Well, I need an equation that contains the quantities that are dealt with in the table here. I've got mass, distance, time, acceleration. Okay, distance and time I can use to calculate velocity, but that doesn't help me find anything for mass, for force. Mass and acceleration does though. Do you recognise this? F equals ma. Nice, straightforward. That's Newton's second law. Interesting. Okay, I think we can use that. Okay, I've got a mass, I've got an acceleration, so yeah, I've got these things. So let's use that. Okay, calculating the missing data. For the crash without seatbelt, okay, so the force experienced, or the stopping force, the force on the dummy, let's say, okay, F equals ma. Let's substitute our numbers in. The force equals my mass is 60 kilograms. Okay, and I'm going to multiply that by the acceleration, which is 467 meters per second squared. I need to just check the units are okay. Kilograms, meters, seconds, everything's good. Okay, so I've checked my quantities. Okay, I've got my units sorted. I've got an equation I can use. I've substituted my numbers in. I just need to solve it. So what do I get? 28,020 newtons. Let's put that in there. 28,020 newtons. Look at that. That's significantly more than the crash with a seatbelt. Okay, so we need to talk about that now. So I've done my calculation. I've calculated my missing data. Check it off. I've done it. Okay, make sure my zeros don't look like sixes or anything daft. Okay, clear. I'm going to use information now to explain how the seatbelts reduce injury in a crash. And explain as a command word. Generally, that means I'm going to have a because in there. I like to use the question to make myself a sentence starter. So let's use some of these words. I can say seatbelts reduce injury in a crash because. Let's start with that. So seatbelts reduce injury in a crash because. Yeah, don't be afraid of using the words from the question in your answer. Now, let's see what we're going to say. They reduce. Look, we just worked out the force for without seatbelt. The force is much less, so we can say they decrease. The force is decreased. The stopping force is decreased. Okay, and I can back that up. I can justify that by quoting some numbers. Okay, so crash with a seatbelt, F equals 10,500. Without, F is nearly 3 times as much. Okay, quote some numbers from the table. Okay, I don't think that's quite enough to get it. That's all 6 marks there. Okay, I've worked my calculation out. I've explained how an injury is decreased because the force is decreased. Why is the force so much less if I'm wearing a seatbelt? Let's quote something else. The acceleration is a lot less, isn't it? Okay, acceleration is much is less. So with a seatbelt, let's just be clear, we're talking about with a seatbelt, acceleration is decreased, and I can say A is 175 meters per second squared compared with 467. That's a huge difference without. Okay, so I can put bullet points here if I want to separate my words a little bit. I can also say with a seatbelt, acceleration has decreased. This is because the time taken to stop is much increased. Okay, so I could say because the time taken to stop is increased. If it takes longer to stop, the acceleration is less. If the acceleration is less, then the force is less. Okay, because time taken to stop is increased. And I can quote that: t equals 0.08 seconds compared to 0.03 seconds without seatbelt. Okay, I could go on if I wanted to. I could add distance travelled whilst stopping is much increased. So if we're slowing down over a larger distance, that's going to reduce my acceleration. Okay, because it's reducing and it's going to reduce the force on the driver. Okay, so that's my 6 marks. I think now I've explained why, I've quoted some things from the table. Okay, go back and just check that you've done everything requested. Okay, I've done that. Happy days, done. All right, that's as good as I'm going to get. I'm going to move on to the next question. Okay, don't forget, it doesn't. If you're not getting 100% all the time, it doesn't matter. 5 out of 6 would be great. 4 out of 6 is pretty good. That's 4 out of 6 is still 66%. Okay. But if you've got a systematic approach to it and you go back and check and you've done everything requested of you, then you're going to be on 5 or 6, aren't you?